Okay, now let's look at page number 12 and let's do 1920. This time we are doing dilation, but we will make the image smaller. So this will be reduction, okay? All right, question number 19. List the coordinates of the quadrilateral ABCD. How many points do we have in a quadrilateral? 4 points, right? If you just list all of the pairs, four of them, I don't know which is which. So we always write the name of the point first, and then we use all of the pair. So let's go in alphabetical order. A, that's name of the point. And then parentheses, and x coordinate from the origin to the left or right. So that is -2 x coordinate. Go down 2, so that is y coordinate, right? Okay. Next point B, from the origin 2 to the right, and 1, 2, 3, 4 down. So 2 comma -4, right? Next one, C, 4 and 3, and D, -4 and +4. Okay, so we can name the points, and I'd like to put name in front of the ordered pair. That's how we name the point. Okay, so that's it. Question number 20. Dilate this quadrilateral by a scale factor of 1/2 from the origin. From the origin. Okay, so we will dilate this figure and we will name A prime, B prime, C prime, D prime. Since we are using origin, it would be much easier, okay? I just don't teach how you calculate numbers first all the time. I want you to think about geometry first so you can apply the same way with the different numbers. Does it make sense? So think about shape first and then calculate later and find a pattern later. All right, so if I make the things smaller, so think about the flashlight and hand and the shadow of the hand, okay? So where is the location of the shadow? That is what we are looking for. No, this is going to be the shadow, right? If we have bigger one, right? So I'm doing backwards this time. I'm looking for where is my location of the hand, right? Where is the flashlight? What is the point of dilation? That is going to be the origin. So this is the origin, and that is the flashlight. So it's not like this projector and screen and hand between, right? So let's think about this situation. This is a tent, big tent. Boy Scout, we have tent, okay, for camping. So you have flashlight not on your face, okay? And you are inside of the tent, and then you have flashlight. Does it make sense? Like that. And then let's think about where is going to be that hand inside and your shadow is outside, like that. What would you like to do first? Draw the line? Yeah, that's a good idea, right? So I will do geometrically, and then I will show you the pattern using the numbers later, okay? It has a nice pattern because we have point of dilation at the origin. If it is not at the origin, you cannot just use that number pattern. So let's do the geometry first, and then let's figure it out. So let's connect the dots between the point D to this point of dilation. And can you find the halfway of this? Because the, oh, okay, undo. All right, let me do it again. Connect the points and think about half of this point. So you're looking for the midpoint between 2 points. Where would be the midpoint? So you will consider half and half, right? So let's figure it out. Where is the point? 1, 2, 3, 4 horizontally. So you go only 2, that is a half. And then same thing, vertically you go 4. And now we go to half, that will be right there. So this is going to be the point, right? Taking half of the slanted line, right? So you think about horizontal length and vertical length, and you take half of each. So that is the idea of the midpoint. Okay, so that is the midpoint of the segment. I need to take half. Why? Because scale factor is half. If the scale factor is not half, 1/3, and I need to find the location of the 1/3. Okay, I will measure that length and then divide equally by 3, and then I will take the first out of 3 spots. Make sense? This is easy because it's just half, and the origin is going to be the number, so it is easy question, but I want you to think about general problem. If I move this figure in different place without origin, and how would you like to deal with it? Same way. Does it make sense? Okay, now let's do a little bit quickly, okay? So think about the distance from this to that, okay? This to that, what would be the halfway? 2 and 1.5, right? Got it? Okay. Next one, from point of dilation to A, what is the halfway? Right there. That is the midpoint on the segment, right? And the other one, the last one, from here to there, what is going to be the halfway? 1 and -2, right? Okay, so let's connect the points. Okay, use a ruler, okay? Okay. I didn't use a ruler and then asking you use a ruler. Right here, that is going to be the shape. Okay, so that is it. Make sense? So we are going to measure the length, and then we will take half of it. And then we can find the location. Now let's find the location of A prime. What is location of A prime? -1, comma, -1. Is it half of the original pre-image? Yes. Oh, that's convenient, right? That happens because we are using origin as a point of dilation. If origin is not point of dilation, it's not like that. So B prime, what was the number? Order the pair. 1, comma, -2, right? And C prime, half of 4 and 3, right? Half is 2, okay, half is 1.5. 2 and 1.5, so that is C prime. And D prime is -2 and 2. Any questions so far? And I'll ask one extra question, okay? All right, let's say size of the pre-image is, you can find the area actually, okay? You can find the big rectangular area, and you can subtract all of the right triangles from the corner. You can find the area. Anyway, don't find the area, okay? Just think about the question. What is the scale factor of the area after the reduction using half as a dilation? Every length gets smaller. Length gets smaller by half, okay? And what would be the effect on the areas? Area gets smaller, right? How much smaller? 1/2 to the power of 2 square of this. So what is the number? Area gets 4 times smaller, okay? 1/4 smaller. Does it make sense? So think about area formula, length times width. That's why we have a square as a power here. Area gets 4th smaller.